video we'll talk about quadratic models. In a linear model, things are increasing or decreasing at the same rate. In a quadratic model, sometimes you're increasing, sometimes you're decreasing, and the point where you change has a special name to it. But before I get into where it changes, let's talk about some other things first. If you have an equation that you want to solve, there are three basic steps. Move all terms to one side, and perhaps combine like terms. And then you have a formula to memorize. Now, factoring is an option if you know factoring, but for this video I'll just talk about this method, the quadratic formula. Then you take your answer and you either simplify it or you convert it to a decimal. So here's a problem. I want to solve x squared minus 5x is equal to a negative 4. So I noticed this term called the constant term, the one without the x on it, that is on one side of the equation, and the other terms are on the other side. So I'm going to move everything to one side. I tend to make the x squared be positive. So notice if I had moved x squared to the left, that would have been a negative x squared. It's doable that way, but I tend to prefer a positive x squared. Okay, so I have these letters A, B, C, and what do they mean? The A is whatever is multiplying x squared. And if you don't see a number, you can always say 1. So there's a 1 times x squared. So at this particular equation, A is 1. B is the number that's multiplying the x. And so that includes the negative. So B is a negative 5. And C is the constant. So C is a positive 4. So I'm going to take those three. A is 1. B is negative 5. C is 4. And I'm plugging it into here. So that means opposite of B. So it's the opposite of negative 5. Eventually it becomes a positive 5. Plus minus means I actually have two answers. One of the answers has a plus sign and one of the answers has a minus sign. So just to shorten things up, I write it that way instead of writing two different answers. And then you get the square root. It's the b quantity squared, so it's negative 5 quantity squared. And then minus 4 is always there. It's always a negative 4. And then A is a 1, and C is positive 4. So let's start simplifying. And down on the denominator, 2 times A, so 2 times 1. So let's start simplifying some things up. Opposite of negative 5 is positive 5. Got that? Negative 5 quantity squared means negative 5 times negative 5 is positive 25. Now this b squared will always be a positive. You won't ever get something like negative 25. It's always going to be a positive thing. And then this negative 4ac might be positive or might be negative, depending. But in this case, I've got a negative 4 times a positive 1 times a positive 4. I've got negative times positive times positive. That will come out negative. And 4 times 1 times 4 comes out 16. So it came out to be a negative 16. And 2 times 1 was 2. Okay, simplifying further, I'll look at 25 minus 16, and I say that's 9. And now sometimes the square root won't simplify nicely, and I need my calculator to convert it into a decimal. But in this example, it does simplify nicely. So square root of 9 is 3, and that's down on the next line. And so I'm saying I've got two answers. One of them is 5 plus 3 over 2, so that's 8 over 2. 5 plus 3 is 8. The other one is 5 minus 3 over 2, so that's 2 over 2. And then both those answers reduce. 8 over 2 is a 4, 2 over 2 is a 1. So I'm saying this equation has two different answers. One is 4, one is 1. Now sometimes when we're dealing with a model, we'll deal with a situation where saying that x is negative doesn't really make sense in the context of the problem. And so even if this formula gives you negative answers, we may disregard the negative thing if it doesn't make sense in the context of the story problem. Okay, moving on. So in using that formula called the quadratic formula, let's concentrate on the thing that was underneath the square root, the b squared minus 4 times a times c. Three things can happen here. The example I gave you, the thing under the square root was positive. It was a positive 9. In that case, you get two different answers, one when you add and one when you subtract. The answers will be different. If the thing underneath the square root, if the discriminant is its name, if the thing underneath the square root is 0, both when you add and subtract, they both give you the same answer. So we say there's only one answer. And you really, once you've done the plus 0, you don't have to do the other answer, which is minus 0, because you know it will come out to be the same. Okay, and if the number underneath the square root is negative, we say there are no real answers. Now, some algebra classes will say there are complex answers, but for this video, I'll just say there are no real answers. Okay, in every parabola, you have what's called the vertex. Now, a parabola is just y equals what we saw before. Y equals a times x squared plus bx plus c. And there's a vertex, and it is either the lowest point when a is 0, or it's the highest point, or, when a is less than 0. My mistake. And so to calculate this, either at the very highest point or the lowest point, x coordinate is always minus b over 2a. Now that is your quadratic formula without your plus minus square root. So that's easy to memorize. If you got the other one memorized, just get rid of the square root part and you've got the formula for the vertex. And once you've calculated the x coordinate, plug that into the equation to figure out a y. Okay. Now, when you go to graph a parabola, you're going to set, just like we did with lines, you're going to set y coordinate equals 0 to find the x-intercept. And you'll solve that by a quadratic formula, or if you happen to know, you might be able to factor. And remember, it's possible that you only get one solution. It's possible there's only one x-intercept. It's possible there's none. There's possible that there's two different x-intercepts. Okay, all three are possible. As with lines, you set x equal to 0 to figure out your y-intercept. Now, there will always be one y-intercept. And then, with the previous instructions, you find the vertex. And then you plot all of these points. You know, there may or may not be x-intercepts, but there's definitely going to be a y-intercept. There's definitely going to be a vertex. And you form a U shape. Now, the vertex will be the bottom of the U, or if it's upside down U, the vertex will be the top of the U. And as with the U, it should rise at the same rate on both sides. Or, you know, if the vertex is the highest point, it should fall at the same rate on both sides. Okay, that's a short little introduction to quadratics.